Okay, so on page 27 we have classification of matter, and we can organize matter. And most of you guys know how matter can be organized. Matter is anything that has mass and takes up space. So that's just a general definition of it. Anything that has a mass or quantity that makes it up and then takes up some sort of space, that is what we consider matter. And then most of the times, under normal conditions, we have three states of matter. Solid, liquid, gas. We've learned that from elementary school coming up, that's a pretty easy thing to visualize, to see. Gases have bigger space. Water has more interaction, but they can move around one another. And then if it's a solid, it's pretty much fixed, and there's no movement around one another. Okay? They say glass is a supercooled liquid. So if anything's a glass, they say there is motion that the molecules have around one another, or the particles have around one another, but it takes place at a very, very, very slow rate. And then they say if you take a look at old houses and you measure the thickness of the window at the top and then thickness at the bottom, that it's thicker on bottom than on top. Okay? So, but that's something that's kind of an anomaly. It's just, you don't think of it that way, but we have matter, and matter can be broken down into multiple things. Okay? So usually, when we first start talking about matter, we have matter at the top, and then we have two divisions that takes place. And this is something that's real general and real easy topic, that one side is going to be considered a mixture, and the other side is going to be considered a pure substance. So what's the difference between a mixture and a pure substance? Well, a mixture is made up of two or more substances that are not chemically combined. So a mixture, if you look on page 28, I'm not going to write the definition down for you, but what it's going to be, a mixture is a combination, a physical combination of two or more of the pure substances, or two or more substances together. So they have examples: wood, gasoline, wine, soil, and air that we breathe. And so they have variable compositions is the key there. They're not a specific composition. They're not a definite composition. They're a variable composition that makes them up. So then when you take a look at mixtures, there's two types of mixtures that we break mixtures down into. And one is called heterogeneous, and the other one is called homogeneous. And a lot of times this is called a solution. So when we say a solution, they go back and forth. So homogeneous mixture is a solution, and they mean the same thing. Homogeneous means there's an even distribution of the particles. And heterogeneous means there's an uneven distribution of the particles. So that's the difference between homogeneous. A lot of times we look at homogeneous and we can't distinguish one part from the other. So if we look at something and we have to define which one it is, and we look at it real close, homogeneous solution, we can't tell one part from the other. We can't. Air, we can't tell nitrogen from oxygen. Water, we can't tell H2O from magnesium ions floating around in there, chlorine that's floating around there. It all looks like one phase. If it all looks like one phase, all gas, all liquid, all solid, and we can't tell one part from the other, that's homogeneous. And if we can indicate and find the different parts of it with our eyes, that means that type of mixture is heterogeneous. Okay? And that's what it describes there. So if you're writing notes on definitions of those, I'm not going to write them up here, but heterogeneous means visibly different parts. You can pick out the different parts. If you can't pick out the different parts, and it's considered a mixture, then it's homogeneous. Okay? If you can pick out the different parts, or different phases, like pop, you can pick out the bubbles, especially if it's carbonated. You can pick out those different parts, different phases, then it's heterogeneous. Okay? That by definition. Now we've got a pure substance. A pure substance, there's two divisions. Everybody knows these two divisions, right? What are they? What's that?
Is it right?
What'd you say?
Compound and element?
Compound and element. So it's one of those two. An element would be that it just has one type of atom that makes it up. So an element, to be pure, it means it's only made up of one type of atom. Compound, a compound is made up of two or more different, two or more different type of elements make up a compound. They have to be different. They can't be the same. Like, for example, O2 is an element. Okay? And you say, well, you got two of them, and they're hooked together with a covalent bond. Isn't that a compound? Well, compounds are hooked together with covalent bonds as well as ionic, but they're going to be considered two different elements, like H2O, for example. Okay? Two different elements when you look at their formula as a compound. If it's one element, ozone is an element. That's ozone. Okay, O3. So they're both elements. This is in just a molecular form. Okay, and molecules could be both compound or element. They fit into both categories. So when we talk about molecules, that is a different type of bonded substance together. Now, these here, we're going to study these tomorrow. And I'm going to give you, I'm going to give you some compounds separate from one another. I'm going to give you salt. I'm going to give you sugar. Okay? And those are two compounds. And they're pure. So I'm going to give them to you separately. And then I'm going to have you do some testing with those two types of compounds. I'm going to have you do some different tests just to see what some of their characteristics are. All right? Then what we're going to do, then what I'm going to do is I'm going to mix the two together. Okay, I'm going to give you a mixture of the two together. And so when I mix them together, it's probably not going to be an even mix. It's probably going to be heterogeneous, even though it looks like it might be homogeneous. Okay? And then what I'm going to have you do, you can think about this, I need you to purify that sample for me. I need you to take that solid sample of sugar and salt, and I need you to purify it for me. Which means I need you to separate it. So mixtures can be separated, by a physical means. These cannot be separated by a physical means. They have to have enough energy to go into them in which to separate them out and they'll form different substances. So that's what I'm going to do. I got a lab set up where I'm going to give you salt and sugar, and I'm going to have you do some tests with it. Okay? And then, after doing those tests, then I'm going to have you devise a way in which you can successfully separate the sugar from the salt. Okay? See if you can come up with a way to allow you to have that separation take place. Okay? Don't look, and then I'm always going to preface this up, don't look it up on the internet. Don't look it up on, you do that, you're cheating yourself. You're cheating your thinking in the process of trying to figure things out. Because a lot of this stuff you guys can access through information that comes up. So I would suggest that you wouldn't do that. But I don't have control over that. To me, that would be cheating. Okay, but it's hard to know when that happens and when that doesn't. So, what do you think? Any questions you guys have? Okay, so we'll look to see if we can do that starting tomorrow, and see if you guys can think of some things you can do in which to do do that little experiment that I have for you. Okay. Alrighty. That's about it. And then we get into filtration, chromatography, and paper chromatography. We'll talk about that later. But I'll give you some clues tomorrow, maybe how you can successfully separate, do some of those things. Okay.